All right, let's get into it. Today, we're going to trace the entire history of API authentication. We're talking a journey from the super simple password days all the way to the cutting edge of security, zero trust.
So let me ask you something. If you're a developer, there's a really good chance you're using JSON Web Tokens, JWTs, for handling user sessions. It's just what we do. But what if I told you that this super common practice is actually what many security experts call a ticking time bomb?
And look, the stakes here are ridiculously high. We're not talking about some minor bug. Getting API auth wrong can lead to absolutely catastrophic data breaches, leaving your APIs wide open for attack. We're talking about hackers literally impersonating your users with full access. So yeah, this isn't just theory, it's stuff you absolutely have to know.
So, here's how we're going to break it all down. First, we'll go way back to the dark ages with Basic Auth. Then we'll see how delegation gave us OAuth and OIDC. After that, we'll look at the rise of JWTs, which were built for scale. But that leads us to the big problem, the ticking time bomb itself. And then, of course, we'll cover the modern fix and finally peek into the future with zero trust.
Okay, let's start our journey way back in the internet's early days, in what we'll call the dark ages, with basic authentication. This is pretty much ground zero.
So what even is it? Well, Basic Auth is exactly what it sounds like. It's a dead simple method where the client just sends the username and password with every single API request. Now, these credentials get smushed together and encoded in base64. And that sounds kind of technical, but the only thing you need to know is that this is absolutely not encryption. It's just a way of packaging the text.
And that right there is why this method is totally, completely dead. Remember how I said base64 isn't encryption? It's just an encoding format. That means anybody who intercepts one of those requests can decode it in like a nanosecond. And poof, they have the user's real permanent password. Seriously, it's like taping your house key to your front door. Just a terrible idea.
So, obviously that huge security hole in Basic Auth got developers thinking. They started asking a really important question. How can I let another app access my data without just handing over my password? And that question, that's what kicked off the whole era of delegation.
Okay, we're about to clear up a massive point of confusion in the auth world. But hey, real quick, if this kind of deep dive is helpful for you, do me a quick favor. Hit that subscribe button and join our community here at @BrandTechAuth. And while you're at it, drop a like and let me know in the comments what auth method you're using right now. I'm genuinely curious. All right, let's untangle OAuth versus OIDC.
So a lot of people get these two mixed up. Let's make it simple. Think of a hotel. OAuth 2.0 is the hotel keycard. It doesn't prove who you are, but it proves you are authorized to open certain doors, right? It answers the question, what can this app do? OpenID Connect, on the other hand, is when you check in at the front desk and show them your ID. It's the authentication layer. It proves who you are before they even give you that keycard.
Now, this need to build massive, sprawling systems, especially with microservices taking over, pushed us into the next phase, the age of scale. And this age was powered by the rise of the stateless token, the one and only JSON Web Token, or JWT.
So what's actually packed inside one of these tokens? Well, a JWT has three parts, and they're separated by dots. First up, you've got the header, which just says what algorithm is being used to sign it. Then there's the payload. This is the juicy part. It holds all the data or claims, like the user's ID and what they're allowed to do. And finally, you have the signature, which is the really critical cryptographic part that proves the token is legit and nobody's messed with it. Now this right here, this was the genius of JWTs, statelessness. Because a server could verify that signature cryptographically without ever having to check a database, any service could validate a token all by itself. I mean, this was a total game changer for microservice architectures. It just let them scale like crazy.
But, and this is a huge but, this is where the story takes a dark turn. That incredible strength, its statelessness, also happens to be its greatest vulnerability. Welcome to the ticking time bomb, the revocation problem.
So let's just imagine a scenario for a second. A hacker finds a vulnerability, maybe some cross-site scripting, and manages to steal a user's active JWT. What happens next? What can you actually do?
Well, here's the terrifying reality. That stolen token is basically a golden ticket. It's perfectly valid until it expires, and that could be minutes or even hours away. The hacker has full, unrestricted access as that user for the entire time. And because your whole system is stateless by design, there's no central kill switch. You literally can't just log them out or invalidate that one specific token. You're just stuck. So, how in the world do we fix this? Well, this brings us to the modern solution, and it's all about debunking the very myth that made JWTs so popular to begin with, the myth of pure statelessness. To make JWTs truly secure, you actually have to bring a little bit of state back into the picture.
The first part of this fix is a really clever technique called refresh token rotation. The idea is, instead of having one refresh token that lives for a long time, every single time you use it to get a new access token, it's immediately killed off, and a brand new one is issued right alongside that new access token.
And this is where that rotation trick becomes so powerful. It lets you do something called automatic reuse detection. So think about it. If a hacker steals and uses an old refresh token, your real user is eventually going to try and use that same one. The server will see that an invalidated token was just used, realize something's wrong, and can instantly kill the entire family of tokens for that user. It forces them to log in all over again. Boom. State is back, but in a much smarter, more secure way. So by smartly bringing state back, we can patch that critical flaw in JWTs. And this whole principle of constantly verifying and never taking access for granted, well, that's the foundation for where all of security is headed. Because these days, it's not just about humans logging in anymore. It's about authenticating workloads, all the services, scripts, and bots that run our modern infrastructure. So, just to recap the whole journey here, we started in the past with simple, crazy vulnerable passwords. We moved to our present, which is all about delegated access using tokens. And now we are entering the future of zero trust, which is all about figuring out machine and workload identity.
And why is this so important right now? Well, think about the world of AI and automated CI/CD pipelines. We've countless different services and software agents that all need to talk to each other to authenticate across different clouds and systems. Using a static, long-lived password for them is just as dangerous as using Basic Auth was for our users back in the day.
This all brings us to the core mantra of modern security architecture. It's the guiding principle of zero trust, and it's simple but incredibly powerful. Never trust, always verify. It means every single request, I don't care where it's from, has to prove its identity and prove its authorization. Every single time.
At the end of the day, security isn't some destination you just arrive at. It's a constant process of evolving and adapting. So now that you know this whole journey, and you understand the real risks that come with stateless tokens, the real question I have for you is, how